Hello everyone, I'm Mustafa Özbek. I was chosen to represent my group, the group Epsilon, in Strength of Materials 210 project. In this video, I'll try to explain you our project and its calculations. First, I'd like to show you group Epsilon's structures, measures, and loads. As you can see here, our roofs L1 is 7 meters, L2 is 8 meters, H front is 5, and H rear is 4 meters. And loads are 50 kilograms per meter square and 400 kilograms per meter square, and our dead live load factors are 1.4 and 1.6, and the rest of the measurements such as cross-section of T and L beams etc. are same for all of us. We were asked to calculate MMV diagrams of the simple beams and columns, the critical section analysis of each beam and column to find maximum normal and shear stress due to the loading exist on the member, and if the stresses are beyond the yield point, the suggestions to ensure the structure member's safety, and last, evaluation of the beam's deflection by comparing the limit value aforementioned. Now, let's start to look at our calculations. We started our calculations from the roof of our structure. As you can see, we first calculated our secondary beams, and we did that by finding all loads on our beams. Loads we found on our secondary beams are all distributed, and we summed them and we found our support reactions. We now have everything we need to draw MMV diagrams for our secondary beams. At this page, you can see that we draw our MMV diagrams, and we have found Tmax and Mmax values. We will use these values in the future to find stresses of our beams. At this page, we started to calculate our primary beams. As we all know, we have 4 primary beams on our roof. So before doing our calculations, we have to name them. And we named this beam, this L beam, 1, 1, and this beam 2, 2. Because these two beams are exactly same and the loads on them are exactly same, we don't have to do calculations for both of them. If we do one calculations, it will be enough for both of them. As you can see here, we have found all loads on our primary beams. We have primary beam's own self-load plus secondary beam's self-load plus the slab plus and the live load. We found all of these loads, and these loads are also distributed loads. Here we calculated our support reactions and we draw our MMV diagrams, and we found Tmax value and Mmax value. At this page, we calculated our primary beams AA and BB. Because our AA beam has a T section and our BB beam has L section, we first found areas of the L section and T section. Here you can see all loads on our primary beam AA and BB. We have our secondary beams as point loads. We have our slab's self-load, our primary beam self-load, and live load. We calculated all of our loads, but this time not all of them are distributed. This page is all about finding support reactions and drawing MMV diagrams. But this time, not all of our loads are distributed. As you can see here, our secondary beams here are point loaded, so when we draw our MMV diagrams, this time it will be different. As you can see here, we draw our MMV diagrams and we found our Tmax and Mmax values. At this page, we calculated columns on the top. As you can see, we draw our MMV diagram for our columns, and because loads on all four beams are same, this diagram and calculations are same for all columns at the top. At this page, we calculated loads on our secondary beams at first floor. As you can see, again, there is the self-weight of our secondary beam, the self-weight of slab, and the live load. Here we calculated all loads on our secondary beam. At this page, we found our support reactions and we draw our MMV diagrams, and we found our Tmax and Mmax values for our secondary beams. At this page, we started to calculate loads on our primary beams. Because our primary beams has L section, first we found area of our L section, and after that we found all loads on our beams, such as self-weight of our beam, slab load, secondary beam load, live load, and point loads of columns on the top. As you can see here, we found all loads on our primary beams. At this page, we found our support reactions and we draw our MMV diagrams. And we found Tmax and Mmax values for our primary beams at first floor. Here, we found all loads on our primary beams again, but this time these beams have secondary beams on them, so not all of loads on them will be distributed. Here we calculated all of loads on our primary beams at first floor, and here we found our support reactions and draw our MMV diagrams, and we found our Tmax value and Mmax value. At this page, we calculated first floor columns. As you can see here, our front and rear columns does not have same length, and that means we have to do two different calculations for our columns. We named our columns A, B, C, and D. Loads and calculations will be same for our column A and B, so we did that here. Our column has 15-degree angle, and that means we will have an axial and a shear reaction at our columns. Here, we found our reaction forces and we draw our MMV diagrams. At this page, we calculated loads and reactions at column D and C. Again, these columns are also has 15-degree of angle. Here we found our reaction forces and we draw our MMV diagrams for column C and D. Here you can see that we found our maximum moment and maximum shear force for our beams and columns. From this page, we started to calculate stresses on our beams. Here we calculated stresses on beam 1-1 and 2-2 at roof. We found our L section's moment of inertia and we calculated our normal stress. As you can see, our beam AA has a T section, and first we found moment of inertia of our T section, and here we've calculated normal and shear stresses for our beam AA. And for our beam BB, we also calculated normal stress and shear stress. Here we made calculations for shear stress and normal stress for our beam CD at first floor. And also we made shear and normal stress calculations for our beam 3, 4 at first floor. As you can see, we calculated normal and shear stresses for our secondary beams at roof. Here, we calculated normal and shear stress for our secondary beams at first floor. Last but not least, we calculated stresses for our columns. Here, we draw this table and we wrote all of our normal and shear stresses at our beams, secondary beams, and columns at roof and first floor. Here we wrote our conclusion. According to the evaluation of stress table, which I showed you, nearly every value of the stresses are below the limits of aforementioned. They are even much smaller than the limit values. However, for the first floor columns, normal and shear stresses are beyond the yield point. In order to acquire safety, we need to increase dimensions of column section. As you can see here, we have our simple stress formula. If we increase the area, we will see that our stresses will decrease.